Today's presentation I'm giving is about Salesforce.com's multi-tenant architecture, and it's subtitled How We Do the Magic We Do, because in my personal opinion, some of this stuff is a little bit like magic. It is pretty impressive stuff. So you will have seen the safe harbor slide a few times already, and it's here again. This basically says you should always base your purchases and decisions upon currently available technology and not on anything in the future that I'm going to be talking about. This deck is pretty much about current technology, so it should be fine, but I will mention any future stuff if I do come to that in the presentation. So my name is Doug Merritt. I'm a principal architect here at Salesforce. I'm based in the UK. I look after Northern Europe, hence the accent is slightly different to most presenters you're seeing this week. And I'm part of the team that help customers understand a bit more about our architecture and help them integrate it into their enterprise architecture. So this is the multi-tenancy is something I speak about a lot because a lot of our customers or prospects who want to become customers aren't necessarily very aware about how we do what we do, because when we start talking about the numbers that we do, the transactions and the volumes and everything, people think that's impossible, it can't happen. And it is true, and so I have a lot of fun actually presenting this stuff to customers, and actually when the light bulb comes on, it's like, wow, you really do that? Yeah, we really do that, you know. So it's a bit of a light bulb moment for them as well. So let's get going. So the Internet of Customers is something that we've been talking about for quite a while actually, and it's very, very important to understand a lot about actually how this stuff actually hangs together. So we've got connected employees using their devices to make sure that they can spend their micro moments waiting in the lift for something actually quite effectively on the device. We've got connected partners, so the ability to have customers, so our customers, so people like Honeywell with their remote control units, they're able to liaise with their partners over the Salesforce platform and actually get some information out of that. We have people who are connecting their customers, so people like Trunk Club, who are a retail fashion outlet. They're able to connect to their customers in all different interesting ways. And lastly, and I think for me personally, the most interesting thing is connected products, because this is where the whole Internet of Things is going, right? Having a thing that's talking to the internet is wonderful. However, you should never forget that behind every thing is a customer. And that's the main thing a lot of people are forgetting about in the industry. And you've got to have the holistic view across everything. So connected products are very powerful. And this is New England Biolabs that have a connected freezer. And we'll talk a bit about that in other sessions at Dreamforce. But the Internet of Things part of the dev zone is just literally up the corridor to your left. And I'd suggest if you haven't had a look at that, go have a look. There's some quite amazing things that people are doing. Technology there which you can implement into your own business processes to actually help your customers get better value out of your products. And that's something that I think is very, very important, and that's what Salesforce can do for you. It surrounds the whole customer and makes that customer the key part of your particular company. And the platform that we have, the Salesforce1 Platform, is enabling all this sort of stuff. So Zimmer, product catalog app, Time Warner with their field sales app, but the custom apps, things like the Honeywell contractor app, they're the ones I think are actually quite powerful, because these actually enable not only collaboration between partners and your company, but also with technology. So the actual control units themselves can talk back to Honeywell and through to the contractor as well. And how do we actually do this sort of stuff? Well, Salesforce platform is the #1 cloud platform in the world, according to Gartner. And it's the fastest way to get from having an idea and actually having a working application. And we do that with a couple of things. We provide all these nice features for you. So the multi-tenant infrastructure, we'll be talking about that today. That's actually the whole presentation I'm going to be talking about. The scale and security are very important. Obviously, cloud database there's identity, there's mobile, there's collaboration, there's a whole bunch of good stuff there. But the thing I'm talking about today is on the left-hand side, the multi-tenant architecture. And this is our marketing architecture slide. And it's really quite nice, it's very pretty. However, it's not quite accurate, because if you look at the bottom there, it talks about the Salesforce1 platform, and that is our entire platform. It talks about the Force.com platform, the Heroku platform, and Exact Target Fuel. Now, I'm only going to be talking about the Force.com platform today, because both Heroku and Exact Target Fuel are hosted in their own data centers, and they work in different ways because they've got different requirements to actually running the business solution they provide. Salesforce1 Community sits on top of that, and on top of that the Mobile One app, and then you have the application sitting on top of that as well. So the Salesforce platform underpins not only the CRM solution and the Service Cloud and the Marketing Cloud and the Salesforce Marketing Cloud and Sales Cloud, etc. It also is where you can build your own applications to run inside your corporations or your organizations. And also you can implement partner applications from our App Exchange. It's sort of like the iTunes of the business software. You can go in there and if you find applications to suit your requirements and install them directly into your Salesforce instance. And we'll talk about how that works a little bit later on actually, because it's all part of the magic that we do. Now, the stuff off the App Exchange can either be free of charge, open source, some is closed source, some is paid for, and you can just install that, pay the money if it's paid for, and away you go. You'll see all of our partners at the North and South campgrounds. There are tons of people out there actually showing you some amazing technology you can hook up into your version of Salesforce. Now, at the core of the customer success platform is the Salesforce platform. It's multi-tenant computing. So what actually gives you that stuff there? Well, we're extremely quick because there's no need to worry about hardware, no software, very, very fast ROI. We do automatic upgrades. That's a magical thing. When customers first come and start talking to me, they say, when I talk to them and say, we do 3 releases a year, and every release that we do will not break anything that you have at all, guaranteed. And they go, what do you mean? I said, well, nothing will break. It'll just work. And they go, no, impossible. Because we've all lived through the upgrades, right? Where, on-premise application, do the upgrade, it takes 6 months, then it just fails. And it's like, costs a fortune just to keep what you had before. Well, those of you who are Salesforce customers, we do a major upgrade 3 times a year, and the upgrade takes under 5 minutes, and it works. And that's pretty impressive. In fact, we're living through an upgrade at the moment. Last weekend and this weekend coming up are actually the upgrade windows for the Winter 15 release. It also very, very innovative. Because we have the automatic upgrades, you can continuously improve your applications and use our technology to help your applications grow. You can build applications to run on any device. We're API first, so that means anything that you create in Salesforce is automatically enabled to the API. And it's very easy to build. And I talked yesterday at Introduction to Force.com presentations across the hallway about how easy it is to build an application on top of this. It's very, very trusted as well because we're extremely transparent. We're holding your data and we're looking after it. So we need to make sure that we tell you about everything we're doing with it, how the performance is. If there's an issue, we tell you, yes, there's an issue and we're fixing it and this is when it's going to be fixed. And then when we have fixed it, we tell you what we did to make it work. Because, we're looking after your stuff and we've got to be open. And obviously it's very, very secure as well. Highest industry accolades around that as well. So we do all the infrastructure services, we do all the application services, we do all the operation services, all the stuff that keeps the lights on. We do all that sort of thing for you. All you have to worry about is focusing on innovation to make your company more successful, or your customers more successful. That's the key thing. And how do we do that? Like I mentioned before with multi-tenancy. So let's get into the meat of the presentation here and actually talk about the multi-tenancy that we have underneath the Force.com platform. These slides will actually be up in the chatter group on the Success platform. So when you log back into Dreamforce.org, you can have a look in there, and these slides will be up there later on today, early tomorrow. So you don't need to take any notes unless you really feel the need. Also, this recording will be up on YouTube later on, and I'll post the link in the chatter group as well. So, how do we do this? We have one cloud with many, many customers. It's using shared elastic services, which means things will grow and shrink as required. And we have something called a production instance. Now, production instance is where we have around about 8,000 customers per instance. This is our horizontal scalability. So what actually happens is, in the diagram, it looks like one version of Salesforce, which is true. There is only one version of, actually, there's 2 versions of Salesforce. There's this one and the next one. That's it. There's no old ones. You're never going to be kept behind. There's only 2 versions, this one and the next one. And it looks in that diagram that everyone's on the same lump of tin. Well, that's not true. We can't actually scale that much. So what we have is these things called an instance. It's a lump of kit that's got app servers and database servers and all that sort of stuff in it. And we'll come to that diagram a bit later on. But that instance is shared about 8,000 customers, and we have 50 production instances. So actually, we can horizontally scale that quite easily. We we do a cookie cutter, and we just keep pumping out more instances, and we put more customers on the instances, and away we go. Each instance is only half full to make sure we've got lots of headroom for scalability. And all of your data that you store in the Salesforce instance is in the same table. All the data is in one big table, and we'll talk about how that works in a couple of slides. But everything you have is all inside this one big table, and your data is commingled with everybody else's. So if you're in the same Salesforce instance as Virgin America, for example, your customer records and their customer records are sitting side by side in the Oracle database. But you're going, how can that, it's going to leak, they're going to see my stuff. No, it's impossible. Because the way we do stuff, everything is separated by your unique org ID. There's something there called an org ID. When you have your own version of Salesforce, that's called an org. And that org has a unique identifier. And that unique identifier is on every record in Salesforce. And part of the queries that we do underneath the covers, we always put the org ID in part of the query to make sure that we only get the data that's part of your stuff. So that's how that works. And we do all the disaster recovery for you, and if you have any encryption inside your version of Salesforce, then also we store the keys to that as well. But there's 8,000 customers roughly using the same platform services against the metadata and the data. That's how it actually works, and we'll discuss how that actually hangs together in more detail in a sec. So what actually is an instance? Like I said before, there's a shared database. It has pivot tables, data tables, metadata tables. There's a cache, an in-memory cache of all this information to make sure it can work very quickly. It looks at the bulk data processing, the multi-tenant aware query optimizer, the runtime app generator, and also the full text search engine. All these tools actually are used to create your version of Salesforce. So whenever you go to a Salesforce page, that page is built for you on the fly. Nothing's pre-compiled. It's built for you on the fly. So we've got to go and look at the common application screens, put your specific configuration on top of that, and your specific version of Salesforce tables all together to build that page for you. And every one of your employees could have a different view of Salesforce. And we do all of that every time on the fly. That sounds pretty impressive to make it scale, and it is. If you actually do a view source on the HTML page that you have on your Salesforce instance, scroll down to the bottom, there's a little comment line telling you how long it took to run inside our data center. It's about 200 milliseconds. That's pretty cool. If you can do a full web app to return all the sort of complex stuff in under 200 milliseconds, you're doing pretty well. And we do that all the time. So, multi-tenancy means a lot to Salesforce R&D as well, because it's one version, like I said before. They don't have to worry about looking after all the old versions. If you think about what Microsoft and Oracle and these sort of people have to do, and I used to work in an on-premise company as well, I had a big book that had version X of my product had to work with version Y of the operating system, with this particular patch level, this particular version of Oracle, et cetera, right? Complete nightmare. With Salesforce, our guys have to worry about, is it going to work? They have to worry about everything else because it's only looking at the one version of Salesforce makes life very, very easy. And if we do find a bug, because bugs do exist, we fix it and fix it for everybody. Now we do a major release every 3 times a year, but we do patches every week. But you don't even know the patches happen. They just happen behind the scenes. Don't need to restart the servers, it just works. So patches happen all the time behind the covers. Now, automation as well, very important. We run about 260,000 of our tests every time they do a release. And how does it actually work? There's something called, also we run your tests. This is actually something called the hammer. So the techies have got a bit of a sense of humor, so we have hammer time. So what happens there is, also shows the age. So what happens there is before we do a major release, we take a copy of one of our production Salesforce instances. We take all the data and obfuscate it so it doesn't have real data in it. And then we run all the tests that you've actually got in your software. Because when you write an Apex class in Salesforce, you've got to put a test against it. We run all those tests. Then we do the upgrade, then we run the tests again and make sure it works. So we actually use your tests to test our stuff, makes it really good, makes it a lot easier for us. And also we do our own testing as well, obviously, to make sure it's going to work for you when we do our release. And the whole thing about the instance architecture is very, very important as well. If we had one big lump of kit, that would be very difficult and also be quite fragile. Something goes wrong, everything goes wrong. Whereas what we have with instances, there's 50 plus instances at the moment in production. So if something does go wrong, it's probably only going to affect that small number of people on that particular instance, or maybe in that one data center. And that will get fixed very quickly and away we go. But it gives us a good way also to do our releases. We can stagger them. So last weekend was half the production instances, and next weekend is the next half of the production instances. And we can scale across all sizes because each of these instances has exactly the same software on it, but maybe slightly different hardware. So we may have a few more database servers on one instance than another one, and a few more app servers than another one. But they're all exactly the same software, it just works, depending on how many customers we have. And then predictability is very important as well. You're going to know that we're going to release 3 releases a year. You roughly know when they're going to be. That's the spring, summer, and winter releases. And that's something that you can bet your boots on. That's what we're going to do. And you'll be able to plan that, schedule that, and we give you a lot of notice as well. About 6 weeks before a major release, you get access to a sandbox version of it while we're still in finalizing it. So you get access to the new version, have a look, see what's happening. And lastly, we actually built our own application development methodology. The reason being, back in the deep dark past, even before I joined Salesforce more than 8 years ago now, a long time ago, about 12 years, we used to use the waterfall approach for building applications like everyone used to do, write the specs, get the specs signed off, write the code, deploy. Well, that wasn't working very well. We had a whole year with no releases, and the bugs were horrendous. So we said this has got to stop. So we built our own agile development methodology called ADM, and we're using that now to pump out 3 releases a year like clockwork. That's very reliable, and it just works. So ADM is something that we do a lot in Tide to actually make life very, very simple. Now, what are the actual design principles that we use when we started developing Salesforce? Well, we use stateless app servers. What that means is when you make a connection to Salesforce, that particular app server process that you're talking to, when it returns your page, it promptly forgets about you. Which means that if that app server goes away, when you next time you make a request, it could go back to a different app server. That's fine. It'll still work because it's not actually keeping state anywhere inside the app server. It's keeping state elsewhere. Keep state in the database, actually. And the database is a system of record. So the cache that we have, that can be invalidated. In fact, we can run the system without having the cache at all. It just works slower. It's something that we do very well. Also, we don't do any database definition language. So whenever you create a table in Salesforce or an object in Salesforce, it looks to you like you're creating your own little database table, right? But actually, you're not. You're creating a couple of rows in a metadata table. If we created an Oracle table for everything you did, it'd be a complete abomination. It'd be so hard to keep track of, it'd be ridiculous. And this wouldn't work because you can't actually create a table in Oracle. You lock the whole system, which is just not going to happen, not going to work. So we don't do any database definition language at all during runtime. We do it during our upgrade windows and sort of stuff for you, but we don't do it during runtime. Now, all the tables are partitioned by org ID. Now, what that means is that even though we have one thumping great table called stuff and all your data's in there, we don't just have one table, actually we have 32 tables. And what we do is we take your org ID and we do a hash on it. Now, hash is a one-way mathematical process. So you take your org ID, we hash it, and we come up with a number between 0 and 31. And that is the partition that you're on. That's also a partition where your app server lives as well. So you've got an app server partition, you've got a database server partition. And that's how actually we can split the load across the instance as well. Because if we had one lump of app servers, it'd be a bit of a bottleneck. So we split it up to 32 and we sort of load balance that way. We've got very clever smart primary keys in our systems and polymorphic foreign keys. We'll discuss that a bit later on. And we do some quite creative daemon normalization. When I went through university and did computer science, we were always told to do third normal form, right? That's the beautiful thing. Well, in fact, that's lovely and gorgeous in a philosophical way. But however, in a practical sense, it doesn't work too well. So there's always some need to denormalize your system to make it work more efficiently. And we do some quite powerful and quite fun things actually behind the scenes to make that happen. And we use every RDMS trick in the book. We've got people here who are one of the most skilled DBAs in the world running Oracle, and also the most skilled Java guys in the world. In fact, we've got the guy who wrote the book on how to tune Java. He works for us now, which is fantastic. And these sort of people that we have really make this thing fly. I don't think there'd be a comparable group of techies in any other organization around the world. It's second to none in my opinion. So how do we actually do this database structure? Well, this is a rough idea about how the metadata tables look. So on the left-hand side, we have the metadata tables looking at the objects themselves and the fields. So we have 2 tables there looking after objects and fields. In the middle is the table called data or stuff. It's where all your stuff lives. And underneath that, we have our character large objects. So things like your big text fields and type of stuff and your attachments and these types of things are all living in this clob table. Actually, no, your attachments don't. They live outside. They live on a different area. We'll talk about that a bit later on. But these are for your character large objects. So your rich text fields, your text area sort of stuff live in there. Now, because we have some interesting ways we do our indexing, because we have our table structures the way they are, we can't use Oracle indexes on that because it doesn't really work that well. So we'll discuss how these things work a bit later on. So we're going to go through each of these particular metadata tables now and actually explain how they work in detail. So the first one we're going to discuss is the objects and the fields in the data. So the object itself has got a couple of fields in it, mainly the object ID, which is unique. We have the org ID to make sure that it's yours. So when you do a query, we make sure everything comes back with the right org ID. If we ever do it, actually we test about 20 times during each transaction. We do a query, we come back with the data, we check that. If the data does not match, if the org ID does not match when it comes out of the database, we'll log you off and red lights will start flashing because it should never happen. It's the last line of resort to make sure that data will not leak. I mean, multi-tenancy is not easy. Even a company like Microsoft, who've got amazingly clever techies and got some brilliant design technology, when they started developing Office 365 about 5 years ago, when they're doing a beta test of it, at Christmas time, there was a very, very small number of users, I think about 3 or 4 different companies actually managed to leak data between different companies in Office 365 beta. Now, Microsoft found that very quickly. They fixed the bug and it's not a problem in production. Obviously, production today, it's rock solid. But just goes to show how hard it is to take a single tenant app, i.e. Exchange, and make it work multi-tenancy in the cloud. It's really, really hard. What we did though, we started off multi-tenant from scratch. All this stuff is what we used to do from the beginning. We knew it was going to work this way. So therefore, we're making sure that it scales up really, really nicely. So the org ID is there, the object name, the org ID, the object ID, and then we have the fields. So this is a relationship because when we get to the data table, you understand why. But the fields contain the org ID again, field ID, object ID, the name, data type, is it indexed or not? What field number is it? Now the field number is important, keep that in your memory. And then on the left-hand side, sorry, we have the data itself. And the data is made up of the global unique identifier. So each row in the table, there's billions of rows in this data table. Each one has their own unique identifier. There's org ID, object ID, the name of the record, and then the values from 0 to 500. So the field number on the right references the field number in the data table. That's how we do that magic joining. So what happens is the data table looks like this. So we have the global unique identifier, the org ID, object ID, and then, column 1, column 2, column 3, column 4. And column 1 in this particular example, the first 2 records are strings. The next ones are dates. The next ones are numbers. So we actually have just character strings. Each of these 500 fields is a character string, and we just shove stuff in it. And then when it comes time actually to access that, we'll convert that to the appropriate data type for you on the fly. So the way that we do the indexing though is interesting, because if they're all strings, how are you going to sort it? Because you can't sort numbers very well, it doesn't work if it's stored in a text string, as you know. So what we do is we create this index object, and as you can see, it's got a string value, a number value, and a date value. So basically, we'll copy the field out of the data table. So let's say value 3 is a date for you in this particular table. We'll copy that value 3 into the date column in the index table and index it. And that's how the indexes work. So actually it becomes very, very easy. And we've also got unique fields as well. So unique fields are exactly the same as an index column, except it's a unique index, not a non-unique index. So we actually use database tables to actually control the uniqueness in your Salesforce instance as well. Now, the relationships is quite interesting because when you've got parents and children, so you have your account and your contacts, for example, or your order header and order lines, or your expense header and expense lines, what happens is all the data lives in the same table. But how do you have a parent-child relationship back onto itself? You can't have links from field 3 back to field 7. It doesn't really work that way. So what we have is a relationship table that does that for you. So we have the org ID, the object ID, the global unique identifier, and then the relation ID. So we go back to another metadata table which describes the relation type. Is it a master detail or is it a lookup? And then we have the target object ID. And so that way we can actually do the mapping between the whole thing for you. So when we do a query, it does that magic behind the covers. Now, all of that is quite interesting. But how do we actually make it scale properly? So like I said before, we actually table hash everything. So everything's done by your org ID, 32, work it out which part you're going to. We have separate connection points to physical hosts. So we have a bunch of physical machines in the environment, and each of those have their own unique connection pools. The app tier is also split, like I said before, and we distribute the metadata cache across all these servers. And that's quite interesting, because if your administrator does an update to your version of Salesforce, we've got to actually invalidate the cache across all these pools, because next time you make a request, we've got to bring back the right page for you with the new metadata in there, right? So if you can't see a field anymore, that's got to vanish off your page. So how are we going to do that? Well, we've got to actually invalidate the cache, because we keep the cache in memory to make it fast. But then if someone does a change, we've got to go and clear it down. And that's actually a discussion for a whole day. That's actually some pretty serious black magic going on under the covers there to make that happen. These guys are very clever. So then moving on to that, what do we do for you for free? So we do a lot of stuff for you for free. The declarative is pretty cool. you're able to point and click and build an application very easily. You don't need to be a techie. Now, if you think about what normally you have to do, you have to get your techies to go and build your database table in your Oracle or SQL server. Then you've got your developers to actually then connect to that database table, and they've got to work out, well, that's the column over there, it's a character string, but is it a pick list? And if it's a pick list, they've got to do it themselves somehow. So, it's all done for you in Salesforce. You just define the database itself, and as a side effect of that, you'll get a screen, you get an API, you get reports and everything. Bulk processing is quite cool as well. We'll talk about actually all of these in detail coming up, except for web services, that I'm not going to discuss them later on, so I'll talk about them now. But every time you create a Salesforce object, it's automatically enabled for REST and SOAP API integration without having to do anything, which is pretty cool. You can also use our Apex programming like a class, and that class can be exposed as a REST or SOAP API as well. So you can get a whole bunch of goodness coming out of this environment just by actually defining a database structure. And the security follows across as well. If you define a validation rule or if you define a database trigger, that will actually work if the data is updated via the UI or if it's updated via the API or if it's updated via the Salesforce1 app or whatever. It's just going to be working. So you define the stuff once and it works everywhere. Let's discuss a bit more in detail about how the declarative stuff works. So, you just go away and you point and click and you build this database system. It's pretty clever stuff. You've got things in there like what field tracking do you need? Now, field tracking is quite interesting as well. For those of you using Oracle and SQL Server, you want to turn field tracking on, that's going to cause an impact in performance because it starts putting database logs, and you've got to start making sure that there's irreputable values stored somewhere else, et cetera, et cetera. With Salesforce, tick a box, that's it. And underneath the covers, we do all that sort of stuff for you. There's no speed penalty whatsoever. I mean, well, actually, it probably is, but you're not going to notice it. It's going to be milliseconds rather than, tens of seconds. So it's going to be a very, very low impact to you when you're running your environment. And there's some good stuff coming on. If you look around your agendas for other things dealing with architecture, one of the things we have is about the large data objects we're having coming out later on. And these things use a technology called HBase that is outside of the Oracle database we get run under the covers at the moment. And that's a nice new feature which will enable all this sort of your field value history tracking is all going to be stored in that HBase database now to make it much more efficient and powerful. And that's what the Wave system can also work upon as well. So now the new Analytics Cloud can talk to that sort of stuff as well directly. Now, like I said before, validation and rules are actually very easy to use. It's just like a formula using in Excel. It's very simple to do, and anybody can do it. It makes life a lot simpler. Just for me personally, the logic's around the wrong way. When you define a validation rule, if it's true, it's an error. My personal, that's back to front, but that's just me. I come from Australia, so actually it's the other side of the world. Maybe it's upside down because of that. I don't know. So if we look at the next thing as well, roll-up summaries. Now, you may think roll-up summaries are quite easy. Well, actually, they're not. Because obviously, whenever you do an update to a child record, we've got to update the parent record. And that actually has to go back through all the iterations and stuff. And this actually is very, very complex to actually go on behind the scenes. We'll automatically do the calculations for you, but you can force a mass recalculation as well if you want to. Now, people think these actually could be just calculated on the fly. When you go to the account object, you want to see when you go to the opportunity object, you want to count up how much data you have in all your lines that you have in your opportunity and put it in the opportunity header. We could do that. That'd be quite slow. Do more database queries. So what we actually do is every time we save a record, we update the roll-up summary field for you. And that becomes quite tricky because it's done in our bulk save engine, which I'll talk about a bit later on. And it also gets invalidated occasionally. So when you change some of the rules, it gets invalidated. We go away and recalculate it for you behind the scenes, sticking it in a batch queue. And the bulk processing is actually quite important because if you look at the way Salesforce does its database triggers, it's different to Oracle and SQL Server. When you have an Oracle SQL Server database and you do a database trigger and you update a record or you delete a record, that's fine. It'll run that trigger on that record, and that's great. What if you delete 10,000 records? It actually runs that trigger 10,000 times. That's not particularly efficient. So what we do is we actually pass your trigger up to 200 records at a time to actually do the processing on it. In fact, we'll launch off multiple triggers and actually pass each of them 200 records at a time. And this is quite quite a unique way of doing things, but it makes it very efficient. It just means that your developers have to understand what we term bulkification, how to write Apex code that actually works with this variable size of records being passed to it. And we create the array, we do the execute the pre-triggers, so the before triggers. We validate the rows using validation rules. We then save them to the database, and we read them back in again. And then we do the after triggers, and then we do the workflows. We calculate the roll-up summaries, and then we update the audit info, and then we shove it in the database. And we do all of that in a big bulk operation, and we spend a whole lot of time making this process work. Because as we know, reading from a database is pretty quick, no real penalty, it's pretty fast. Deleting is relatively simple as well. A bit slower, but it's relatively simple, because you've got to update indexes and stuff. But updating is the absolute worst, because you could have to actually change records, do roll-up summary changes, change indexes, and do all sorts of stuff as well. It becomes quite ugly. So updates are pretty ugly. And we're doing our utmost to make updates as quick as possible, but also as reliable as possible. And we've done a very, very good job, and it just works very nicely. So it just makes life really simple. So we do a lot of optimization behind the scenes in this bulk process to make it happen. And what we do is we sort all the records by primary key first before we try and do a database update inside to Oracle. Now we do that because it just makes it more efficient for the indexes. We also operate on tables in a deterministic order. What that means is we will always use the tables in a certain order no matter what query you do. So if you query these 14 tables, we're going to actually do this update in that particular order. The reason we do that, it stops deadlocks in the Oracle database under the covers, because if I start a transaction, update this one record, I need to update this other record, and then you started a transaction, you updated this second one, then you need to update the first one, well, now we've got to call it deadly handshake. Because I want this and you want that, but we can't get it because we've both got a transaction on it, so we can't actually hold it. So it's called a deadlock, and then things get killed and rolled back, and it's really ugly. So we try and avoid that at all costs because it slows things down. Also, when you change the data type, so if you change from a Boolean to a string, or a string to a date, or date to a string, or whatever you want to do, some things aren't valid, obviously, but if you do that, then what happens is we'll actually copy that column to another column in the data table as a new type, and then get rid of the old one later on. We don't try and do it in situ. It doesn't actually work particularly well. And we do background processing all these mass changes. So what we'll do is whenever you do a big update of stuff, we'll actually do things in the background. So if you notice when you do a big bulk load of data, use a data loader or some other tool like that, and you do a search, it may not find the data you just loaded, because the search engine's still catching up with the big data you've just done. And again, with roll-up summaries, we do a huge data load in, the roll-up summaries may take a little while to catch up, but you actually get notified of that in the actual screen. And the recycle bin, it's quite a cool thing if you think about it, because normally this is an operating system feature, but we do it in the application. So when you delete a record, it doesn't actually get deleted. It gets stuck in the recycle bin, and you can bring it back. The minimum, I think it holds it there for 12 hours, and I think it leaves it there for up to 3 weeks, depending upon how much data you put in your recycle bin. And the thing is, we keep track of all the parent-child relationships and everything, that sort of stuff, even fields and objects. So the interesting thing is, let's say you've got the account and you deleted an account. That's great. Your administrator then adds 3 more fields to the account object. Then you undelete it. We bring it back and it still fits. That's quite a clever thing. Also, what if they delete 4 fields out of the account, then we do a restore? It still comes back. So we take care of all that sort of stuff behind the scenes for you. Now, searching is something that's quite important as well. And searching is anything but simple. So what we have is your primary database on the top left-hand corner, and it's being backed up all the time to another database running in the same data center. That's the straight down part. When you do a search, we actually store our search values not in Oracle. We store the search values in something that we use under the covers flat file system called Fileforce Extreme, FFX. So we call it Fileforce Extreme, and we shove all the indexable bits. So your Word file extraction, your PDF file extraction, your text fields, all this sort of stuff gets shoved into this search repository. And we actually use Lucene as the search engine with some customization built on top of it. We're moving out towards something called Solr, S-O-L-R, another Apache open source technology to actually do the searching for us, make it more efficient. It's currently in pilot at the moment, and it's working very nicely. So inside your production instance, it's primary running at the moment, you've actually got your real data top left. We copy it across to the search engine, and then we have an index backup going across to the other engine as well. So we have your data stored nice and securely for you, and obviously then we have replication across to our other data center where your instance is backed up to. I haven't mentioned that before yet, but you have your instance, your org runs in one instance. That instance is replicated to another data center. Your data lives in 2 data centers only, okay? It doesn't live everywhere around the world, not like Google. Your data is only in 2 places with Salesforce. So, multi-tenancy delivers blazing performance. You see our growth, it's exponential in the number of records and the number of transactions we store. We're doing 131 billion transactions in Q2, that's last quarter. We're doing roughly 2 billion transactions a day. And a transaction is you clicking a button on a page or doing an API call that you import 10,000 records. That's a transaction. And under that, we actually have about 20 database transactions per Salesforce transaction. So we're doing, 40 billion database transactions a day. That's a heck of a lot. And it works very quickly. As you can see, the latency is going down. So we're doing many, many more things, but we're actually getting faster at doing it, which seems quite bonkers, but actually we're doing it very, very well. Now, the core data storage is also quite interesting. Nice little diagrams coming up here. We have 4 copies of your database at all times. So what we have is your production version is up here. And what happens there is, so your production database is here, your application servers are here, so we write data into your application, into your database from your application server, and that's then replicated in a rack array, so that's actually backed up for you automatically. Now this gets copied across to a whole different database section as well, so that's a standby cluster. And what happens there is this can fail across to this one if something happens with this database. Then across the network to your other data center, we have an async replication. This happens when it can. It's going to be slightly delayed, but not too much. But this database here is always going to be exactly a copy of your database at a certain point in time. Might be 2 minutes behind or 10 seconds behind, depending on how much data is going down the wire. That database will always be consistent. You won't get half data and half not data being there. It'll always be exactly right. And then we have 2 online backup copies as well. So we have the replication happening between these 2 and a backup copy online as well. So your data is nice and safe. We use very powerful technologies on our SANs to make sure the replication happens very quickly across these networks. Now, how do we do our query optimization? Well, it's actually very, very powerful. What we have is a requirement for doing consistent SQL, because obviously in the Oracle, you need to have very consistent SQL to make it perform very well, but the flexible schema we have makes it very, very hard. And these statistics are very important because you need to understand who you are, what you do, where you are in the hierarchy to make sure we do the query properly. And we'll talk about that in the next thing. And the sharing model actually is very, very important around this because the optimizer looks at your user visibility. So what data can you see? You know the role hierarchy we have in Salesforce? If at the top of the role hierarchy, you can see all of Salesforce. If at the bottom of the hierarchy, you see 4 records, that's all you can see. So depending upon where you are in the hierarchy, you can see more data. Then we have the filter selectivity for the actual query. So if you put a where clause on there, that actually changes how things work as well. Now, depending upon those 2 particular bits, we'll actually do a Oracle query that then runs against the Salesforce database and then comes back with a result set. And how do we do the optimization? Excuse me. So if you're a low visibility user and you don't have a filter, so basically you're saying, give me all the accounts, but you only can see 3 accounts anyway, what we'll do is we'll do a nested loops join, which actually then drives the data to see actually what you can see, because there's a sharing table here that keeps information about all the records you can see, and we use that to actually determine that. But if you put a where clause in there, we'll actually use the index to work out what data you can see, then filter out the ones you can't see depending upon your sharing rules. So we do that either which way around depending upon how we do it. If you can see all the records in the system, we'll use a hash join, not a nested loops join, but a hash join, and then use a data table to resolve that as well. So there's quite powerful things behind the scenes. Force.com, very powerful language behind the scenes. It looks like Java. If you build anything in Java, it looks very similar, except it's got inherent capabilities to do our Salesforce object query language, SOQL. And that is built into the language, makes it really easy to develop with, and away you go. Now, Apex is a scalable, scalable application environment. It's compiled and stored in the metadata. Everything in Salesforce is metadata. And that's how it works. We stick it in the metadata tables. When you run it, we actually pull it back out, run it through an interpreter, and away we go. It's got some very powerful features. It can do bulk DML processing, it can do email in and out, you can do messaging with SOAP and REST as well, and you can declaratively expose classes as web services. Now, what makes us different though, right? We are social, you've got feeds, you've got profiles, you've got mobile capabilities, we're open to all the integration technologies, and it's real time. Everything you do in Salesforce is real time, and that's the main benefit of it. It's very, very easy and powerful to do. Now, the whole thing is powerful multi-tenancy, which is why the customer success platform is just going to work for you. It's going to scale, it's going to fly, and that's what happens. Now, I'm basically finished the presentation, about 3 seconds late, sorry about that. But there are some more things to look at here. If you go to the developer.force.com/architect subgroup on our website, that's got some very, very powerful patterns and information around some technology behind this. We can talk, there's actually a white paper about multi-tenancy up there. It's very, very detailed and very capable to actually understand how that all works. It is patented, so we're happy to talk about it, because if you steal it, we're going to sue you, so that's fine. And there's also a great web microsite about security as well, because something that you really should focus upon when you're building applications. Now, the other sessions around infrastructure as well, these were all yesterday, but you will be able to have a look at the recordings and the PowerPoint decks in their groups. And there's a couple more today and some tomorrow as well. So please have a look at these other sessions if you'd have some more information. Don't forget to go to the Salesforce1 Platform keynote, which is on Wednesday at 2 p.m. in Moscone South. It's well worth a look. You're going to see some quite interesting things from Mike. He's going to announce a whole bunch of new stuff, and it's very, very worthwhile going along to that. And lastly, please fill out your surveys in the Dreamforce app. We like getting the feedback from you to help us make this presentation better and also make Dreamforce better for you. And with that, any questions, please? Yes, question.
I hear that you duplicate the value in the data column into the index.
The question was, do we copy the data rows into the indexes of the indexing? Yes, we do. We actually have replicated data everywhere. That's a denormalization that we do to make it more efficient. Anything else? John, can you turn the mics on, please? No, just yell.
Do you have the NA0 instance, which is a bit different from the other instances?
Yes, we have NA0, which is different. It's one of the oldest ones. We're trying to get people off that.
Are you going to move the tenant, the organization out of it to the regular?
I'm not sure, really. If you're on NA0, you could talk to your sales rep to get some information about that. I'm not quite sure if you're going to be moving you off NA0 anytime soon. But it is different to the rest of the ones because its database is not UTF-8 enabled, so it's not multilingual. Yeah, so talk to your sales rep. You're actually able to move your Salesforce org from one instance to another instance. That is possible. People do that all the time. In fact, we'll be doing that when we go to European data centers. So that is going to happen. So you can actually move off. It will involve downtime, though, so you need to weigh the pros and cons. Okay, next question? Yep.
You mentioned that you run tests on the customer data. So when you bring the customer data over to the QA environment, the data is encrypted. So do you also bring the encryption keys there so that you can unencrypt it? How does that work?
The tests we run are not actually on. The way that works is when your test classes actually have got plain text in there for doing your own data creation. You don't actually use the data in the database as the test class data.
Okay.
And so all your data actually is in your test queries. Mm-hmm. So actually they're not encrypted anyway when you're actually doing the test classes. It's all in your code. So we don't need to actually copy your keys copy it across, but it doesn't actually affect anything. It's fine.
Okay, so yeah, the actual data is not being used. Okay.
Yeah, that's fine. Okay, sorry that we have to finish out of here. If you have any further questions, please grab me. I will be outside just after here so we can actually go through any other questions you have. Thank you very much.